Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Quratul Amin Hiwan Azmi, metric number 1170288. Today, I would like to present the introduction of the first experiment, which is diffraction grating spectrometer. In this experiment, we have studied and we have conducted the experiment, which is related to continuous spectrum. And continuous spectrum is a part of electromagnetic spectrum. Generally, we know that the electromagnetic spectrum is a continuum of all electromagnetic waves arranged accordingly to its frequency and its wavelength. And the electromagnetic energy passes through space at the speed of light in the sinusoidal waves. And in the picture above, you can see there is a picture about of sinusoidal waves of electromagnetic spectrum. And the electromagnetic spectrum has arranged accordingly to its from the shortest wave to the highest wave. The shortest waves are the gamma rays, and the longer waves are the radio waves. Next slide. We know that this experiment is about continuous spectrum, and there are two types of spectra. First, light spectra, and second is continuous spectra. And here I am going to focus on continuous spectra because this experiment is about continuous spectrum. And in this theory, it is mentioned that when light produces all the colors of the visible light, it is called continuous spectrum. And spectrum here means resulting array of color. And it is called continuous because there is no distinct beginning or end to anyone about the fades continuously, but it fades continuously to another. And the source of light are produced by heated solid metal filaments. And this experiment will use a diffraction grating to produce spectra from incandescent light bulb and from gas discharge tube of mercury. And if you can see the above, those are equations that we use in this experiment. First, lambda equals to d sine theta, and second, n lambda equals to d sine theta. The difference between both is just the n, and n here means the integer number called order number. And next slide. The objective of this experiment is to find the angle of diffraction grating of light spectrum, and then to find the light diffracted and its relation to the colors. And the last one is to become familiar with the use of the diffraction grating spectrometer. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syahira Nabila binti Muhammad Fauzi. My metric number is 1170298. Okay, so now I will proceed with the literature review, as you can see over here. Okay, so this is a picture of the philosophers and scientists before. Okay, they have studied about light since the era of ancient Greece, but they have different perspective about light. From the era of ancient Greece until Ibn al-Haytham era, they claim that light is a matter of wave. But until the era of Newton, he studied and found out that light is a wave and particle properties. This is what we call the duality of nature. So, we can see that electromagnetic From the experiment we do observe the visible light in the range from about 800 nanometer until the 400 nanometer. So, light is electromagnetic radiation, a form of energy that moves at the speed of light. The energy of light is dependent on its wavelength and frequency. This wavelength and frequency is inversely proportional. As the wavelength increases, the frequency will decrease. Okay. Common type of spectroscopy are infrared, ultraviolet, and visible spectroscopy. Based on our experiment, we use diffraction grating to produce spectra from an incandescent light bulb and from gas discharge tube of mercury. So we can observe light spectrum. So light spectrum can mean the visible spectrum, the range of wavelength of electromagnetic radiation which our eye are sensitive. This spectrum occurs when the light is separated into its component wavelength, then produce a ray of color. The different wavelength produce different color. So there are two types of spectrum, which is continuous and this thing starts now.
Okay.
So there are two types of spectrum, which is continuous and discrete. But based on our experiment, which is diffraction spectrometer, we do observe the presence of continuous spectrum. Continuous spectrum occurs when the light produces all the color of visible light. This kind of spectrum does not have distinct beginning or end to any one color, but rather one color fits continuously into another. As the wavelength of light increases, the color become violet, blue, green, yellow, orange, and red respectively. It is important to understand the physical process that are occurring that give rise to the diffraction phenomenon. That's all, thank you.
Warahmatullahi wabarakatuh. I am Marahani Alia binti Muhtar, matrix number 1170278. So right now, let's move to the methodology of the experiment. So as you can see right now, this is a sample of the apparatus that we used in the experiment. So we have the collimator, the light source, the diffraction grating, the telescope, and the angle of the reading. So firstly, focus the collimator and telescope for the parallel light. Turn the telescope to P to view the image of slit. Then move the mercury source to decrease the distance between source and slit, so that to make sure that the image become clear and bright. Secondly, make the slit narrow and center the image of the slit exactly on the crosswire. Third, turn the telescope to Q so that the vernier reading is altered by exactly 90 degrees. Next. Number 4. Place the diffraction grating G in its holder on the table until the image of the slit by reflection at the surface of G appears. Number 5. Lock the telescope and turn the table until the reflection image of the slit at the surface of G appear. Adjust one or both of screw L, M until the image is at center of field of view. Lastly, read the vernier and with the telescope lock turn. Lastly, read the vernier and with the telescope lock, turn the table so that the reading changes by exactly 45 degrees and G is perpendicular to the light. For the second procedure, it is about the angle of the diffraction. Okay, step number 1, move the telescope to the right or left to see the first order of green color. Number 2, record the vernier reading. Number 3, repeat step 1 and 2 for the second order and fill the table provided. Number 4, then move the angle of telescope to see the first orders for other spectrum colors. And number 5, record the vernier reading. Lastly, Use the equation of n lambda equal to d sine theta to calculate the wavelength. That's all.
Assalamualaikum and a very good morning. My name is Nur Farihan binti Ahmad Khairi. Matric numbers 1170289. So today I will show you the result for the experiment 1, and this slide show you the result for the table 1, which we have to find the angle and the diffraction rating for the green color. And we have to find the order for n is equal to 1 and n is equal to 2. Next. Okay, this is the second table, which we have to find the angle and the wavelength for the other spectrum or colors, which we have to find for the 6 other colors. The first one is violet 1, violet 2, blue, blue-green, yellow 1, and yellow 2. Next. This is the formulation that we use. And the next one. This is the questions that we have to answer. So for the first one, the question is, we have to calculate the grating spacing D for the green color and its error. So for the grating spacing D, we use the formula, which is D is equal to n lambda over sine theta. And this formula is the equation number 3 in the lab manual. And for the error, we have to find the means of the diffraction grating, and then we have to square it, and we get the answer for the error, which is 8.62 times 10 to the power of -7 meter. For the next question, number 2, we have to use the D for the number 1 to calculate the wavelength of the spectrum colors in table 2. So we just have to use the formula lambda is equal to d sine theta, and the d we have to use d from the number 1, the answer for number 1. And next, this is the discussion part. And for the discussion part, the question is, we have to discuss the precaution measurement needed for this experiment. And from the research that I do, I find the precaution measurement is, number 1, the experiment have to be done in a dark room to avoid error in the presence of surrounding light. So this means that you have to do this experiment with the light switch off. And for the second one, we have to make sure the spectrum is at the crossing line of the telescope. So the spectrum have to be at the center of the telescope, so we get the angle at the precise measurement. The third one is, we have to ensure the illuminated slit is at constant and fixed position through the experiment. So we don't change the position of the slit through the experiment. The fourth one, read the angle reading at meniscus level. So you have to read the angle reading at the eye level. And the last one, ensure that the illuminated slit is at the center before the experiment begins. That's all from me. Thank you.
Bismillahirrahmanirrahim. My name is Wani Raju Atira binti Hussein, matric number 1170303. Today I will explain to you and present to you some ayat from Al-Quran about the diffraction of light and also some application in today's also about the diffraction of light. So So this is Surah An-Nur ayat 35 that is about reflection of light. It says, Allah is the light of the heavens and the earth. The parable of his light is as if there were a niche and within it a lamp. The lamp enclosed in a glass. The glass as it were a brilliant star lit from a blessed tree, an olive, neither of the east nor of the west, whose oil is well nigh luminous, though fire scars touch it like upon light. Allah doth guide whom he will please light. Allah doth set forth parables for men, and Allah doth know all things. And this ayat explain about how this light of God, when Allah likens something as the parable, Allah will take example of something that the man will know and the man will understand. As for example, in this ayat, the light of God is, we know that it is actually far greater than any example or any of his creation. So in this ayat, Allah used a more understandable term for us, his creation, to understand. So we know that among of the many light that exist in this world, we know that our light is actually far greater than any of the light. As for the application into this world, we know one of it is prism. The prism is a block of glass that are capable of refracting light that pass through it. One of the famous effects of prism is rainbow. The refraction of light that occurs in a prism also has the result of splitting white light into its component colors. This splitting is because of different wavelength of light travel at different speed when crossing into a new medium, such as the glass of prism. Next application is spectrometer. A spectrometer is an optical spectrometer is an instrument to measure properties of light over a specific portion of the electromagnetic spectrum, typically used in spectroscopic analysis to identify materials. So spectrometer is the device we use in this experiment to measure the wavelength and the angle of diffraction of the visible light that pass through the diffraction grating, and the wavelength that we calculate from this experiment determine the color of the light that pass through the grating. That's all from me. Thank you.